use this problem to show some new things and also to review a little bit. We won't answer the question perhaps that is listed here exactly. So what we're going to do is to use this data, estimate the regression, show you what this scatter diagram looks like, and then we're going to do some new things, talk about some correlation, testing for correlation, and then go back and talk about testing for the significance of the regression that we've estimated. Alright, so let's look at this problem and see what we need to understand so that we can estimate this regression first. The data in the table below shows the annual growth rate and return on shareholders' equity for the top 7 drugstores chains in 19 whatever. Estimate the regression equation in which the return on shareholders' equity is explained by the annual growth rate in the company. Alright, so this problem doesn't tell us which is the x and which is the y, and we're going to have to work that out. So let's go to our whiteboard and talk about that. In general, y is explained by the x variable, or you can turn that around and then you can say that x explains y. Alright, what you're going to have to understand here, of course, basically, is the fact that, draw a simple diagram. Okay, that given a particular value for x, we can then predict what the value for y will be. Okay, so let's be clear about this, so that we start with an x variable and we wind up with a y variable. So x is the input to the system and the y is the output to the system. So whatever words you use to describe this, x comes first and then the y comes next. Alright, so let's go back to our problem and see if we can find out any hints from that. Alright, so estimate the regression equation in which the total return on shareholders' equity is explained by the annual growth rate of the company. Alright, I said before a little while ago that in general y is explained by x. Alright, so the return on the shareholders' equity is the y variable, annual growth rate of the company is the x variable. Alright, we're going to bring this data to Excel and quickly get the sums that we need, and then we'll go back and work out the estimated regression. So the first column is x, next column is the y. We're going to get x squared, xy, and we'll need y squared for the things we're going to do today. So x squared, so that x is squared, xy, x times y, y squared is the y squared. Copy that down and then get our sums of each of those columns. So the sum of the x's is 114.3, and then copy that across and we get all our sums. Alright, so let's transcribe all this information to another page. So first of all, we have that sigma x is 114.3 x3. Sigma y is 117.8. Sigma x squared 2147.99. Sigma xy 2008.1. And sigma y squared 2030.1. And the sample size, number of data points, count them up, and you'll see that we have 7 observations. Alright, so our calculations will start with x bar, the average x, sigma x divided by n, sigma x 114.3 divided by 7 equals 16.33. Next, y bar, the average y, sigma y divided by n, sigma y 117.8 divided by the n of 7 again, and that's 16.83. We can then get our sum of squares of x, s of xx, which is sigma x squared minus n times x bar squared. Sigma x squared is the 2147.99 minus n of 7 times x bar 13.33 squared, and the result for that is 281.3. Next we can get sum of squares of xy is sigma xy minus n times x bar y bar. Sigma xy is 2008.1 minus n of 7 times x bar 16.33 times the y bar of 16.83, and the answer to that is 84.26. Alright, that's all we'll need for the estimation, but for what we need to do later, let's also get the sum of squares of y, syy, sigma y squared minus n times y bar squared. Sigma y squared is 2030.1 minus the n of 7 times y bar 16.83 squared, and the answer to that is 47.36. Note that the sum of squares of x must always be positive, just like the sum of squares of y must always be positive. The sum of squares of xy doesn't matter, could have either greater than or less than 0.